Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to make you another video. In this video, what I wanted to make is how to create your own data set so you can work with data. Because sometimes you might not be able to find the data set that you want. And if you can't find the data set that you want, then you can create your data. So that's what we're going to do. We're going to create a data set in Python, and we're going to use Google Colab to do that. So the first thing we're going to do is we're going to import the libraries that we need to create this data set. So we're going to import CSV, which is an inbuilt module in Python. We're going to import random, which is an inbuilt module in Python. And then from datetime, import datetime delta. So, and then we're going to generate the sample data. So start date equals date time 25, 1, 1. The data is going to be 3 columns, being date, state, and total sales. And the states is going to be state A and state B. Now we're going to have a for loop for I in range 365. So it's the for loop is going to generate, well, actually 730 rows of data, but it's going to do it 365 times. So it's going to generate 365 iterations, but since there's 2 elements in states, so we're going to multiply 365 times 2, and it's going to be 730. And then so we're going to have a for loop within a for loop. So we're going to say for state in states, date equals start date plus time delta days equal I. And if you wanted to make that week, I'm sure you could make it weeks. If you wanted to make it months, I'm sure you could make it months. But we did days equals I. And total sales equals random.randint 1500 to 2500. So you're going to have you're going to be able to make a random integer from 1500 to 2500, and then we're going to append the data to date and total sales to data, which is data.append date.strip time year month day, comma, state, comma, total sales. So this particular data set is going to have 3 columns of data and 730 rows of data. So we're going to write to the CSV. So file name equals sales data 365 rows.csv, and then this is code within Python, so you don't need to use pandas for that. With open file name, comma, mode equals W, comma, that's W means write, comma, new line is a space as file. Writer equals csv.writer file, and writer.writer rows data. So what it does is it's going to write every row onto a CSV file and then print data written to file name. And so you can see here we've got data written to sales data 365 rows.csv. So now what we have done is we have created a CSV file with 730 rows and 3 columns of data. So now that we've got our data set created, what we're going to do is we're going to do a sample t set with a large sales data set. The null hypothesis is there is no significant difference between the means of the sales of the 2 stores. And the alternate hypothesis is there is a significant difference between the means of the sales of the 2 states. So what we want to do is we want to import the libraries that we're going to need to execute this next script. So we're going to import NumPy as NP to perform the numerical computations. We're going to import pandas as PD to create a data frame and process the data. We're going to import scipy.stats as stats to perform the scientific computations. And we're going to import matplotlib.pyplot as plt to visualize the data. So the first thing we want to do is we want to load the CSV file. So df equals pd.readcsv sales data 365 rows.csv. So we've loaded it up. And now what we're going to do is we're going to create a pivot table of that because you've got state A and state B. So pivot df equals df.pivot table. Index is the date. Columns equals the state. Values equals total sales. Ag func equals sum. And then we're going to print the df. We're going to print pivot df. So you can see here where we have printed the pivot table, and you can see that you've got the date, and then you've got state A and state B. Okay, now what we're going to do is we're going to calculate the sample means and standard deviations. So mean A is np.mean pivot df state A. STDA equals np.std pivot df dot state A. DDOF equals 1, and that's degree of freedom equals 1. NA equals len pivot df dot state A, and that's the length. So the length is going to be 365. And then we do the same with mean. You've got mean B, STDB, and NB, which is exactly the same, except it's going to be for state B instead of state A. Now we're going to calculate the standard error. SEA equals STDA divided by NP square root NA. And it's exactly the same thing for state B, except instead of using A's, you're going to use B's. And then we calculate standard error. Standard error equals NP dot square root SEA squared plus SEB squared. Now we calculate the degrees of freedom. And so in the green, that's the degree of freedom that came with some of the code that I found. But I was having some problems because it didn't really work. I'm not going to say it didn't work right, but it didn't work the way that I wanted it to in Excel, because I've taken all of this code in Python and I have converted it into Excel for something else that I would like to do. Although I haven't made videos in Excel, I've just made the videos in Python, but all of this code has been converted to Excel. And then so this code wasn't really working the way that I wanted it to work. And so I asked my good friend Google, and then Google said to calculate the degree of freedom for a two sample test. It's NA plus NP minus 2. So that's what I did. So there's different ways that you can calculate the degree of freedom. And the thing is every different hypothesis test might have a different way to calculate the degrees of freedom. But because I couldn't get the degree of freedom to work the way that I wanted them to do, I decided just to use a very simple formula of DF, that's degree of freedom, equals NA plus NB minus 2. And really, it should be DOF, really, because we've got a DF already. And because we've got a DF already, I think it's going to cause problems. So we just make it DOF. So rather than DF, because the DF is your data frame and DOF is your degree of freedom. So we'll just make that DOF. And now we calculate our p-value. P-value equals stats.t.sf. SF means survival function. Brackets, np.abs, that's abs is absolute value. T statistic, comma, DOF. And it's a 2 times 2 because it's a two-tailed test. And then we're going to determine our critical value. As alpha is your level of significance, or your significance level is 0.05, which pretty much is the standard number that they use. T critical equals stats.t.ppf. ppf means percentage points function. 1 minus alpha divided to DOF. And then we print all the results. And then so when we print the results, you get the mean salary. Company A is 1992.25. Company B is 1997.73. Standard error is 21.62. T statistic is negative 0.25. Degree of freedom is 728. And so that's 730 minus 2. T critical is 1.96. And then it gives you degree of freedom again, gives you p-value of 0.7999, and it says that you failed to reject the null hypothesis. There is no significant difference. But we see here we've got 2 degrees of freedom. So we're going to delete one of those because we don't need 2. And then we're going to conclude it. So the conclusion is if NP abs, that's absolute value, T statistic is greater than T critical, you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. And so what we said here was the T statistic is, if the absolute value is 0.25, is less than T critical of 1.96. So we're going to fail to reject the null hypothesis. There's no significance difference in the average values. And so that's what we've done. And then the next thing that you can do is we're going to plot the histograms, and we're going to plot the mean lines, and then we're going to add the title. And so this is the histogram that we have plotted. Blue is company A, peach is company B, and then you've got the company A mean in blue and company B mean in peach, dashed lines. So what I'm going to do, I didn't do this before, but I'm going to run it. See what happens. So basically what we're going to do is we have to run the large data set again, because that's the data set is saved locally. And if the data set is saved locally, then whenever you close down the program, then the data set will be closed down as well, or the CSV file. So you see that we ran the data set again. So you've got sales data 365 rows. So we're going to run this again. And it worked. We didn't have any errors. And so it fails to reject the null hypothesis. But what we can do over here, it says 1500 to 2500. Let's say 1000 to 3000. And see what happens. See if that changes. See if that changes our means. So the means are still about the same. a little bit different, but they're still about the same. And it failed to reject the null hypothesis because it's still about the same. So what we could do is we can try it again. We'll say 5,000, 1,000 to 5,000, see what happens. And what you could do, see this is giving you means that are very similar. It's giving you means that are very similar. And because the means are very similar, it's not going to reject the null hypothesis. So what you could do was you would have to make a different data frame. You would have to make a different data frame with one column for state A and one column for state B. And then what you would have to do is you would have to create random integers for state A and then random integers for state B and give them different parameters. And then that would give you a different means. And then the different means would be able to say reject the null hypothesis. But in this instance, since the means are going to be very similar, you're not going to get a failed to reject the null hypothesis, which is what I was you're not going to get a reject null hypothesis because the means are too close together. So what I might have to do is I might have to create a new data set with different means. And well, there we go. I've showed you how to do it. It's not really exactly what I would have liked to have done because I would have liked to been able to change the means of state A and state B so we can either fail to reject the null hypothesis or reject the null hypothesis. But we can't do it in this instance, unfortunately. But I've already made the video, so I'll put the video up just so you can get an idea of the code. And then what I'll do is I'll try to make a new data frame, a new data set that will give you a different means for company A and company B, which would enable you to see how you can reject the null hypothesis and fail to reject the null hypothesis. So I've already made this video, so I'll put it up. So thank you so much for watching my video. If you like my video, please like and subscribe, and I will be making another video for you on this topic very soon.